Okay, this is the chapter 6 and chapter 4, on exponentials. And let's kind of start into it. Sometimes this first section is the most difficult section, but it may be a section you want to come back to as you work through the chapter. Tuition is currently $1,050. If tuition has been increasing exponentially by 7% per year, predict the tuition in 5 years. Okay, let's look at the problem, go through it. Ms. Carr's worked these out. Tuition is currently that. That's just the problem itself. Review the basics of exponentials. Exponential growth and decay is a function that grows or shrinks at a constant rate. The equation can be written in these forms. Okay, the amount, 1 plus the rate, raised to an x power, or we could say f of x is a times b, where this is 1 plus r. You see, it's 1 plus the rate that it's growing at. A is sort of like the initial amount. And r is the percentage growth rate or the decay. And b is the growth factor or the growth multiplier. Since the powers of negative numbers behave strangely, we're going to limit b for right now to positive values. Okay, same problem, determine a, r, b, x. A, which we said was the initial, is our tuition. The r is the rate. What is the rate that it's growing? 0.07. So then b would be 1 plus 0.07, which is 1 plus the rate. And your x would be the length of time. In this particular problem, x is the length of time. So substitute the given values. You've come up, you plug in, that's the basics, you plug in what you know all the way through, and then you will evaluate it. This is where I've put it into the Desmos calculator, and that's the answer. And it said the predicted tuition will be, of course, tuition's money, so we just automatically note around it to 2 decimal places. Okay, here's an equation, and it says to interpret this equation. So you want to say what the initial amount is, what this means, and so forth. It says determine the values a, r, b, and x, which is time, or sometimes you see it as t, in relation to the formula. P of t represents the amount at a certain time, so 1,000 is the initial amount or the amount at 0. So 0.83 is b equals 1 minus r. We find r to be 0.07. But what's happening? You're having a decrease here. Because it's less than 1, it means it's going to decrease. And it's decreasing at a rate of 7%. And that's the explanation behind this expression. And that's what they wanted you to do. Now, we're told to find an equation of an exponential passing through the points 0, 3, and 318. Well, 0, 3 would kind of give you your initial point, wouldn't it? So let's look. F of x is a, 0, 3, we can find a, and a is 3. So we plug in, the x was 0, 3, anything to the 0 power is 1, so a is 3. Okay, it says find an equation, so we've got to keep going. We found that a was 3, so now we have 3 bx. So we're going to use the other point, where 18 is the f of x, and 3 is the x. So 18 divided by 3, we get 6. B cubed is 6, and if we take the cube root, it would be 1.82. So b is 1.82. So we've got to find our growth rate here. B is 1 plus r, so if 1 plus r is 1.82, the growth rate is 0.82. So x represents the amount of time there. this would be your function. 3, remember we found that was our initial, 1 plus 0.82, that's the growth rate. R would be the time. Or you could have made this as alpha of t equals 3 plus 1.82, and that would have been a t. Either way, that's not really what's the most important. Okay, there's another problem. You deposit $1,000 in a savings account that earns 1% monthly. Find the amount in the account after 10 years. So this is a way that you do use the exponentials. This is your compound interest formula here. A of t is the account value at any time. T is the number of years. A, little a, the amount starting in the account, which is a lot of times it's called the principal. And R is your annual percentage rate, or your APR, just your rate of your loan, so to speak, your annual rate. And K is the number of compounding periods. Like if it's quarterly, it's 4, semi-annually 2. So be familiar with all that. Monthly is going to mean 12, because 12 times a year. Okay, that is the problem, again, just written down. Now, let's identify the variables. A, the original amount is 1,000, sometimes referred to as a principal. T, for 10 years, the rate was 0.01 compounded monthly. Okay, now let's go plug it in. A of t, so 1,000, 1 plus 0.01 divided by 12. 12 is the K. We split it up, and 12 times 10, so K times the time. Look at that. Be sure you see where all the variables go. This is just an expression. You evaluate this to find the amount at the end of 10 years. So we actually plugged in, and here's our execution into the calculator. We round it to the nearest hundred, so the amount in the account would be $1,105.12. So 2 decimal places, we're talking money. And that was compounded monthly. Okay, the next problem we talk about is compounded continuously. So we have a little bit different formula when we start talking about continuously. It's almost like daily, but a little bit more often. Continuous growth is a e to the rx. E is the base of the natural logarithm, and this is one of the main places that E is used. Not the only place, but one of the main places. A is your starting amount, R is your rate, your continuous rate, and of course T would be the time here. Let's identify A, the amount you start with, T, 10 years, and the rate is 0.01. So we substitute in. Really, it's a simpler arithmetic than the other problem. Here is your execution in your calculator, right here, and we got 105.17. Slightly more than when it was compounded monthly. Compounded monthly was 105.12. We made 5 cents more by having it compounded continuously. So that's a terribly low interest rate period there. So you're not, and $1,000 is not that much money to put in the bank. It's better than nothing though. Okay, one more little problem I think here. A bacteria population grows at a continuous rate of 4% per hour. How much would a population of 1,000 bacteria grow to in one day? Just one day. So let's look at the problem. A bacteria population grows at a continuous rate of 4% hourly. How much will the population of 1,000 bacteria grow in one day? Well, we're identifying everything. We start out with 1,000. Your time. 1 day. That's 1 out of 365, because remember, time is yearly, and rate is 4%. So if you substitute in, remember now to change it to 1 divided by 365 because it's just per day. Okay, this is where we've done our calculations. The setup, put in, that's the input into Desmos, that's the output. And we round it off for the answer, it would be $1,011. Okay, so this is just kind of an overview for you to see how exponentials are used and be familiar with your formulas and what the little individual values do mean.